In this example of the use of an OSR, the accumulated value of the timer will be output to a BCD display when the push button PB is pushed. The TOD instruction converts a binary value of the source, in this case the accumulated value of the timer, to a 4-digit BCD number and stores it in the destination. In this case, the destination is an output module connected to a decimal display. The TOD instruction will perform this conversion whenever the rung is true. Without the OSR, the instruction would perform multiple conversions and transfer them to the output as long as the push button PB is pushed. The output display would be changing while the button is pressed. When PB is released, the last value converted would be displayed at the output. With the OSR, when the button is first pushed, the TOD will only do one conversion. Another conversion will not be done until the push button is released and pressed again. This is the simulation of the program using a one-shot to freeze the accumulated value of a timer for an output display. I have stopped the simulation to point out that the value shown in the timer as the accumulated value is the decimal value and the same as shown on the output display on the left. The value shown below the destination address in the TOD instruction is the decimal value of the BCD representation of the decimal value. The BCD code is covered in another video. This ladder logic program uses a combination of two timers and a counter to cause a light to turn on based on the status of the float switch FS. If you look at the rung with the light output, you see that there are two conditions that will turn on the light. The first condition is when the counter done bit is a 1 and the T4:5 timer done bit is a 1. The two timers are connected in an oscillating configuration. Therefore, the T4:5 done bit will be turning on and off every second. The counter done bit will be a 1 the first time the float switch contacts close. The alarm light will flash after the float switch closes and continue to flash until the SS switch resets the counter. If the float switch is closed when the counter is reset, the light will turn on solid. The OSR keeps the count up counter from incrementing when the float switch is closed and the SS switch is closed. Observe the simulation of the alarm monitor program. The two timers are continuously oscillating. When the float switch is closed, the alarm light will start flashing and continue to flash even if the contacts on the float switch open. If the float switch is open when the SS switch is closed, the alarm light will go off. If the float switch is closed when the SS switch is closed, the alarm light will be on solid.